Where does a single atom end? Anywhere. Look anywhere. You'll need a microscope, a really powerful microscope, but zoom in on any point of the physical world around you. Now, we don't have the technology to get beyond the smallest part of the atom, but let's just imagine we can. We can see it, we can witness that. What gets smaller than the quarks that make up this atom? Because it's there. You take one of these quarks, which is a fragment of an atom, because you get them. There's this thing called a hadron collider, and it literally is like this 10-kilometer circle somewhere in Europe or something like that, and it's literally just for smashing atoms. They smash atoms and collect the bits and pieces that blow apart from them, and those are known as quarks, or fragments of atoms. Now, when we examine these, you can see that that quark itself is made up of something. It gets even smaller. It gets even smaller. Now, let's keep going. Let's imagine that you can continue to witness and observe the fragments of these fragments of an atom, a single atom. A single atom. Where does it stop? Where does it stop? All that's stopping us is the technology of seeing deeper into it. That goes for the other direction too. Looking out into space, we don't see where its end is because we can't see the end. You know? We don't know how small a piece of an atom can be because we can't get that small. We can't see that small, but it's there. It's there. How could it not be? Why would something disappear the closer you get to it? You're going to reveal more of that thing itself. And you may come to name and label different parts of it, like a quark or a proton or neutron, ion. But it's all the atom. It's all the atom, no matter how close or far away you are from it. So when you look at this in a broad scale, you can imagine that this entire universe is an atom. And we are on a very microscopic level of this universe. Like, take for example your own skin. You look at your skin from a distance, or you look at somebody from a distance, it just appears like this kind of tannish, skin-colored, just area. But you get closer, and you see hair follicles, you see pores, you see the cells of the skin you see the cells that is making up this skin. You get even closer, you can see the reptilian looking fingerprint designs embedded in every millimeter of your skin. You yourself are like an atom. I mean, you are atoms according to science and physics. But you and your being as a vessel, as a single organism, are in a way an atom. And we're all kind of like atoms floating around. But where's the end of you? Where's the end of these atoms? You keep going, keep going, keep going. Quarks, that's the newest one right there. What's smaller than that? And where does it go? What are we going to do to keep going deeper, or closer into this world? I've had this thought that once you get to a certain closeness, you can see the pattern of the entire universe once again. And then you'll slowly start zooming in on a galaxy or, a star system. But it's weird stuff when you think about the idea of the microcosms and the macrocosms. Because where do they begin and end? on a very fine, minute, tiny level, and on a very large level as well. Where are these things, in essence, coming from? What are they created out of? It's not a quark, because you could observe this quark and look further into it. I'm not sure if we have or not discovered tinier pieces of atoms, or, I mean, tinier than a quark. But that quark is made up of something. That quark is something. So once you are able to identify the pieces of that quark, what are those pieces? Move in on those pieces, and it just keeps. And like I said, the only thing that's holding us back from this is the technological ability to zoom in further. I mean, we could probably get really close until we can join with the thing we're trying to look at itself, but it's a level of resolution or focus, detail, of actually being able to look and see it what it is, you know, because up that close, it's not going to be easy to tell what you're looking at. But something's there. Something's there. It doesn't disappear just because you're getting closer to it. How could it? Where would it go? Where could it go? Just because you got close to it means it doesn't exist anymore? So, I don't know what this video is about. I just started rambling. I guess this video is going to be about how tiny does an atom get. So, thank you for watching, and I will be back with more.